And this time we're going to do hyperbolas. So I'm going to graph a hyperbola and then discuss it in a few different ways. So two different types of hyperbolas, they really are very, very similar. I could have one where we start with an x squared, over 4, and subtract a y, or vice versa. Always helps when these numbers are nice and square rootable. Like before, I'm just going to show you how to do this. We take the opposite of this number, comma, the opposite of that number. So my center is at -1, comma, +2. Let's graph this thing, -1, comma, +2. If x comes first, then from my center, I go side to side by the square root of this number. So I go over to this direction to 0 and then +1 and -2, -3. And those 2 points are actually my vertices. I'll make them nice and big. Unlike the center, they're actually parts of this graph. Then, again, if x came first, I go up and down from my 2 vertices by the square root of that number. So I go down 3 to there, and making kind of small dots. Fuzzy on there too. And 1, 2, 3, I go up and make small dots. And then I connect the diagonal dots with dotted lines, which represent my asymptotes. If you did this correctly, the asymptotes should meet and go through the center. From there, all I've got to do is start at the vertices, which are actually part of my graph, and kind of get gently drawn in, gently sucked towards those asymptotes on either side. And there it is. Like we did with ellipses, we can think of this in a couple of different ways. Like we did with ellipses, we can set this term equal to 0 if y were equal to 2. 2 minus 2 is 0, 0 squared is 0, 0 over 9 is 0, and subtracting 0 doesn't do anything. We can kind of cover that up and then solve for the x values. We are going to multiply both sides by 4 so that x plus 1 squared is equal to 4. X plus 1 would therefore equal plus or minus 2 when I take the square root of both sides. And x should equal -1 plus or minus 2. This all happens when y was 2. 2. And so you notice we're nice and symmetric. We are 2 on either side of that point, -1, comma 2. I can't make this equal to 0 and solve this equation. If I tried -1 for x, -1 plus 1 is 0, 0 squared is 0, 0 over 4 is 0, and 0 minus something is just the same as minus something. Minus something equals 1, okay? Minus some things equal 1. But what happens if I multiply both sides by -9? I get that y minus 2 squared equals -9. And when I take the square root of both sides, oh, wait, square root of -9 is not a real number, and this simply doesn't work, which is why I don't have anything when x equals 0. Notice when x equals 0, or I guess in my case, -1, although didn't equal anything for 0 either, there is no corresponding y value. The third way is a little bit weirder. Most people are very, very familiar with what a circle is, so doing some transformations to a circle isn't so weird. People are not as familiar with what the base case, I guess x squared minus y squared equals 1 of a hyperbola looks like. So it is centered at 0, 0. Its asymptotes have a slope of either 1 or -1. But we could take that base case and do both translations by -1 horizontally and +2 vertically, and dilations by 2 horizontally and 3 vertically, and arrive here as well. So a little bit of a weirder process because people are less familiar with what the base case of y squared minus, or x squared minus y squared equals. What if, on the other hand, it were y squared minus x squared? I'm going to do it on the same graph here, and I'm just going to change this from here on out. I'm going to change this to a positive in the middle and a negative out front. Okay, most people would write the positive term first and the negative term second. The center is still identical to where it is. Those little dots are now identical to where they were, but seeing as it starts with y to find my vertices, instead of going left and right, I go up and down by the square root of 3. I'm going to go to there and there. Those are my vertices this time around. From my vertices, I go side to side by 2 and arrive at exactly those same 4 dots that we had before. And so the asymptotes are in the exact same place. So just this time, I end up with an up-down facing one. If the y squared bit is positive, then it's up-down. If the x squared part is positive, then it is side to side. Give me 1 sec. Here was the case from the ellipses, which I drew by hand, but didn't look nearly as nice. If I change this to a minus sign, it will be a hyperbola. If I change this one to a minus sign as well, I have nothing. But if I go like that, now that the y squared bit is positive, it goes up, down. Let's take a look at our case now. So we did 2 different things where we had x plus 1 over 4 and y minus 2 over 9. And again, we subtracted it. And that should look like our original case of the hyperbola. We can still kind of see it over there, that black hyperbola on the sides, where the center seems to be at -1 comma +2, right around there. And if I simply switch these, I'm going to copy and paste. And if I switch this one to a negative and this one to a positive, we get what was a green case over here, what is a blue case over there. And it looks pretty good to me. Okay, that'll do it.